There are a lot of electric heaters installed and put in processes all over the world, and not one of those heaters runs without a temperature controller, a sensor, a relay, or some sort of a thermal device. Four devices combine together to make what we call the thermal loop. The thermal loop consists of the control, the relay, the heat source, and the sensor. It's really common for people that are tasked with designing electric heating systems to not focus on the temperature control. Most of the people tasked with designing electric heating systems are dealing with a mechanical product in nature. It bears pressure, it creates temperature, it's got flow to it, and so those things are all looked at very carefully. But those things don't really work very well if you don't have the proper control in it. So a lot of time and consideration needs to be put into the temperature control mode for that application. There are three main types of temperature control that can be used in any heating system. There's on-off control, there's proportional control, and there's PID control. The thermal loop is a system of components that all work together to keep your process at a steady temperature. The primary device in this system is the temperature controller. The temperature controller receives input from a sensor that's actually installed in your process. You have a temperature that you want to maintain, whether it's freeze protection or 1,000,000 degrees, and that sensor has to be able to accurately tell the controller what the actual process temperature is. That's called a process variable. That controller then makes a decision to send a signal to some sort of a relay that allows voltage or power to be applied to the heater itself. When the heater turns on, it applies heat at a rate that will eventually satisfy that sensor, and then the sensor sees that it's above the temperature and it shuts the system off. A controller in the thermal loop is designed to maintain a specific temperature over a specific period of time. The reliability and capabilities of each type of controller varies greatly. So with on-off control, for example, a less precise application, a proportional control application may be something that needs to be a little more precise, and a PID loop in a temperature control in the thermal loop is extremely precise. We're going to talk about each one of these methods today. On-off temperature controllers are the most common type of temperature controller out there. Good and reliable, rugged. As a matter of fact, this sensor is the one we use in every single ready-to-ship power blanket that goes out the door here at Power Blanket. These controllers are made up of a device inside that can sense temperature, and then it can open and close a relay to allow power to flow to a heater or to turn a heater off and on. These controllers are very reliable. You can think about maybe the last time you ever replaced a sensor in your oven at home. On-off temperature controllers also come in this format. This is an on-off temperature controller very commonly used to switch single-phase power loads in heat trace or small heaters, and they come with a bulb and capillary sensor, and the sensor is attached into the controller to a thermostat that's built inside of the unit, and that thermostat has a relay that again allows the power to be gated to the heater to turn it on and off based on the temperature that's set in this controller. Proportional controllers are another type of temperature control. A proportional controller like this Power Blanket GHT controller is used to control a process at a little tighter temperature than with an on-off controller. These units have a sensor that's attached to the process, power coming into the process, and a way to hook up to the process to run the heater. These units have a relay inside of them. They have a microprocessor that can basically make decisions based on temperature and when they turn on and when they turn off. And they provide a lot tighter control, plus or minus 5 degrees around the set point. A PID controller is the most accurate form of control. This is a really simple example of a PID controller. Here we have an 8th DIN red line controller that has a thermocouple input and has a way for power to be applied to the unit and a way for power to go to the load. Again, just a really simple example. What's happening here inside this controller is it's receiving an input from this thermocouple at a sampling rate of multiple times per second. This controller can then take that temperature sensing reading from this thermocouple or RTD and make adjustments to the output to the heater over a very short period of time. PID controllers literally have no overshoot. They can get right to the temperature and hold it dead on. So if you're heating a great big huge tank of tar, you don't need a PID controller. A proportional or on-off controller would work just fine for you. But if you're trying to keep a gas stream at a very precise temperature, or if you have of vapors or solids that will settle out below a certain temperature. This controller is the best controller for that application. Very precise and very accurate.